Okay, good evening to our lecturer, Dr. Aida. Okay, today we're going to introduce to you about nuclear energy, and this is our team members, Kishan, me, and Ruhesh and Awangkku. Okay, first of all, I'm going to give a small intro about this topic. Okay, as an introduction, nuclear energy comes from splitting atoms in a reactor to heat wave and into steam. This steam will eventually turn a turbine, which will produce kinetic energy, and the kinetic energy will generate electricity. And for nuclear energy, there has lots of benefits, and some of them are: nuclear fights climate change. It means it does not produces too much of waste, and nuclear generate jobs, and it will eventually provides jobs to the youth and upcoming generation. And nuclear protects our air, which means it has less pollution. Nuclear boosts international development, which means we can be uh, uh, connected to other countries with our nuclear power plants. And nuclear power electric vehicles means we can produce nuclear powered vehicles, which will lessen the carbon monoxide and carbon dioxide emission in the air. So for our extra, the benefits of nuclear energy extend far beyond carbon-free electricity too. For example, nuclear power space exploration, as medical equipments, provides potable water through desalination, supplies radioisotope for cancer treatment, and much more. And I will pass my next slide to our friend Kishan. Thank you.
Hello, hi, my name is KIESHENTREN. Thank you to NADESWARAN. I would like to continue my presentation regarding of basic construction of nuclear power plant. Okay, what's meant by construction? Basic construction is the activity where a nuclear power plant is built and its system, structure and component put into operation. In simple words, when we build an house, we need to see the location, the things need before we construct, and in while construct the house. Same goes to the nuclear power plant. Okay, constructing a nuclear power plant. Okay. First, location. Where will we need to build the nuclear power plant? It have to be in large in area, since because the component we use all in large in size. Second, it has two natural water body, so that water is most needed to build a nuclear power plant to generate AC current. Third, it must be safe for radiation, since nuclear power plant could emit radiation nearby its power plant, so it's much safe for all living things. There are three main steps. First, we need to get the license from the government. Second, components and commodities, the things we use to build the nuclear power plant. Third, manpower, such as design the power plant by the engineer and do the core works such as contractors. So we need the manpower. Let's see about the cost. The cost to build is high, but the cost to maintain is low compared to fossil fuel and gas turbines. Okay, this is the construction example. Figure 1 shows Sivas nuclear power plant near Poitiers, France. Second, Baraka nuclear power plant, United Arab Emirates. That's all from me. I would like to pass to AWANGKU Azam. Thank you.
My name is AWANGKU AZZAMUDDIN, and I will explain about the basic principle of nuclear energy. The nuclear energy produces electricity in much the same way other power plants do. The chain reaction produces the energy, which is turned into the steam, and the pressure of the steam turns a generator, which produces electricity. But the difference is in how the heat is created. The power plants that run on fossil fuel burn coal, oil or natural gas to generate heat. in a nuclear energy plant, heat is produced from splitting atoms, a process called as nuclear fission. Nuclear energy or nuclear power plant, the containment structure has two types of water reactor, which is boiling water reactor and pressurized water reactor. First, boiling water reactor. The nuclear reactor creates heat that is used to make steam. Then, the steam turns a turbine connected to an electromagnet called a generator. And finally, the generator will produce electricity. Next, the pressurized water reactor. The high pressure prevents water in the reactor vessel from the boiling. The superheated water is carried to a steam generator which is made up of many small pipes. Then the heat in this pipe is used to turn a second isolated supply of water to a steam which is in turn used to drive the turbine. The water from the reactor is pumped back into the reactor vessel and reheated. The steam from the turbine is cooled in a condenser and the resulting water is back to the steam generator. Okay, this slide we can see these two types of water reactor. Boiling water reactor and pressurized water reactor. As you can see on the boiling water reactor, this is how the nuclear energy works and generate the electricity. And we can see the difference in the containment structure, which is the pressurized has a pressurizer between reactor vessel and the steam generator. There are many countries use the nuclear energy to generate or produce the electricity. In this slide, we can see there are three different power plants from the three different countries that use the nuclear energy. First is Barakah Nuclear Power Plant from the United Arab Emirates. These power plants using the pressurized water reactor. Second is Walfa Nuclear Power Station from Wales, and it's using boiling water reactor. The last one is the Saint Laurent Nuclear Power Plant from France, and it's using pressurized water reactor.
So let me see the example of the nuclear generation site. Okay. This is the example of the nuclear power generation site. Tokyo Electric Power Corporation TEPCO Kashiwazaki Kariwa, which is located in Japan, and the net capacity of 7,965 megawatt. This Kashiwazaki Kariwa has 7 boiling water reactors with a gross installed capacity of 8,212 megawatt. The first 5 units of gross capacity 1,100 megawatt each, and the 6th and 7th units each have capacity of 1,356 megawatt. The first unit began commercially operation in September 1985, and the last unit became the commercially operational in July 1997. And then the operations at the plant were ceased in May 2012 due to the Fukushima nuclear disaster. TEPCO has been implementing measures at the plant to meet the new safety guidelines by Japan's Nuclear Regulatory Authority. All the reactors of the plant are expected to be restarted by 2021. As a conclusion, the construction of building a new nuclear power plant includes in construction delays due to extremely expensive price, public opposition, and the changes in regulatory environment. Moreover, nuclear energy continues to increase in cost while other technologies such as wind and solar energy are becoming more economical. This is because there is lack of skill and engineers who can install the equipment in the nuclear power industry. There is no changes in the economics of nuclear energy. It will be hard to get a lot of investment in nuclear energy over other multiple alternatives that exist today's energy industry. And then these are the references we collect the data. I'll include it in the description of this video. That's all from us. Thank you.